Good morning. This is the 11.2 vector in space. As we go over the vectors in the plane, now we're going to expand the notion to three-dimensional space. So before we get to the vectors, we need to introduce the geometry of space. So, a point in the plane, right, will be denoted by an order of pairs, 2, 5, 7, and 2. In space, we actually have three dimensions, so the depth, length, width. So we need three values, so three numbers to represent a point. So we should have an order triple instead of order pair. So here is our new definitions. In three-dimensional space, we introduce a system, the coordinate system that has three parts. Okay, we call it three-dimensional coordinate system. Consists of three axes. Okay, so the x-axis, the y-axis, and we have additional the z-axis. Okay. Now, if you look at this down here, I have, now we change the orientation a bit different. So you think about maybe your tabletop, the flat surface will be our original plane, the XY plane, okay? And such that the x-axis is actually pointing toward you, okay? It's pointing toward you. The y-axis is the direction of the original x-axis. So the y-axis is the horizontal axis that point to your, I'm sure from the computer, it will be to your right. Okay. So if you look at here, the x-axis pointing toward you, the y-axis to the right, and the z-axis point to the ceiling. Okay, upright. So we have three axes. Now these three axes will make up three quarter planes: the xy plane, the yz planes, and the xz planes. So what they're going to look like? The xy plane will be your actually desktop that you're sitting on, right? So the flat surface, that would be the xy plane containing the x-axis and the y-axis. We also have the YZ plane. The YZ plane is actually your monitor, okay? If you're sitting in front of the computer, your monitor, okay? So that's a vertical plane, okay? And then there is an XZ plane. So the XZ plane will be, it's also the vertical plane. It's actually looks something like, you probably can't see it well from, I guess, it'll be vertical like this, okay? It's go toward you, okay? And we have 8 octants. So basically these XY planes, YZ planes, and XZ plane, that'll cut your space into 8 equal regions. So we call octants, okay? Now, once you have defined these three axes, or this new three-dimensional coordinate system, we will be able to locate a point in space by an order triple, okay? For example, if I say, how do we locate the points? Can you plot the points? Where is the point 3, 2, -1? Okay, 3, 2, -1. So notice in this case, we have the x coordinate is 3, the y coordinate is 2, and the z coordinate is -1. Now notice that the x coordinate now is pointing toward you. So if you actually do the countings on the x-axis, you actually have the 1 here, 2 here, 3 there. So it should be 1, 2, 3. And then in the negative direction, -1, -2, and -3 in that order. Okay. And then for the y-axis, it's pointing to the right actually. So it's gonna be 1. It's gonna be 2. It's gonna be 3. Right. So it's gonna be 1 here, 2 here, 3 there, and the other direction will be -1, -2, and -3. And for the z-axis, this is 1, this is 2, this is 3 up here, and there's a -1, there's a -2, and -3 there. So if you locate the point 3, 2, -1, what we can do is we start from the origins, right? So we count 3 units to the front. So we'd go 1, 2, 3 units in the x direction. And then 2 in the positive y direction. So we actually go in the y directions here. So let me draw it this way so you can see. So this is in the plane, right? So we're gonna go 1, 2. Okay. So it's gonna be somewhere over here. It's not on the z-axis, by the way. And then we will go down. My graph, it's harder to see. We're gonna go down actually 1 unit because of z is -1. Okay, so if you drop down like 1 unit, again, grab this one. Yeah, it's hard to imagine. So basically, it just down 1 unit from here. So this point right here is the point that we're looking at. Okay, so basically 3 units front, 2 to the right, and 1 below the surface of the xy plane. Okay, so that is the point. Now, when we're in the new systems in this 3-dimensional now, the equation that we often have in the past will now change. So, for example, in this plane, when I ask you to graph, when you graph these equations, say y equal x squared, can you graph that? Well, you know that's a parabola in xy plane, right? So you have the x-axis like this, you have the y-axis like this, and you know, okay, that's graph of the xy in xy plane. That's the parabola, y squared. Now it's no longer true because now we have the depth or the height when we have orientation like this. So if you grab this in xy planes, it actually go like this. Again, we change orientation, so be aware this is your positive x, this positive y. So if you grab this like on your desktop, on your tabletop, when you draw on the paper, your parabola would go like these, right? Right? Here, in the xy plane, in the xy plane here. But the difference now is because there's no z involved. So that means when z equals 0, z equals 1, z equals 2, you still have the x, y's coordinates satisfy these equations. So it's satisfied for every x and y and for every z. So this is where z equals 0. When z equals 1, So you add basically up here, and then you have another parabola in the plane z equal 1, right? That's 1 unit up when z is 1. And then you have the z equal 2. So you can see that when you after you draw, it's not just a two-dimensional parabola, but it looked like a I don't know how to describe it. Not good at drawing three-dimensional things. So it's gonna look like this, right? Except of course it's going to go toward the right infinitely. Okay, so now we have the three-dimensional objects. It's not a curve anymore. It become a surface. Okay, so in three-dimensional space, the equation involving x, y, and z now represent not a curve, not a line. It would represent a surface. Okay. Look at a couple examples here. Number one, can you describe the surface represented by the following equations? A, what is y equal 3? And B, what is x squared plus y squared equal 4? Again, when we are in the plane, these are easy, right? So in the xy plane, things easy. We know this how that look like. Well, if an xy plane, recall that's going to be what 1, 2, 3, and that is the horizontal line y equal 3 because this is x-axis, this is y-axis. And when b x squared plus y is equal to 4, we know that too. It is what a circle center at the origins and radius 2. So this is our circle. Radius 2 is -2. So that is the graph of this equations. Now we're in space now, so that means there's a z involved. There is a z involved. Now in this case, the z doesn't actually involve. You don't see the z in it. So you can think of that as 0z. So technically, y equal 3 here is really 0x plus plus 1y plus 0z. So it doesn't matter what z you have or x here have, then the y coordinate is always 3. And that's why you have the lines here. But if you have this z involved, let's look at how it's go now. It's wait. Right, so I have the x, y, z, so three-dimensional space drawn. Okay, so this time I'm going to draw the y actually to the right this way instead of a little bit here. So he just like we're looking from an angle from above. You have the y-axis to the right, the z-axis toward you, and then the z-axis to the rooftop. Now, all right. So how do you graph the equation y equal 3? Okay. So where is y equal 3? Y equal 3 is here. Okay. So y equal 3 is here. Now notice that means any point with y equal 3 satisfies the equation, right? Regardless of what x is, what z is. So you see this point is equal to 3. This point, I think my 1, 2, 3. Yeah, so my yeah, that's right. So 1's supposed to be here, 2, and then 3 is here, 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 here. So if you look at carefully, well, you think that all of these points he has the y equal 3, right? But don't forget that we have the third dimensions. So that is, if you go up or down, the y stay at 3. If you go forward and backward to move into the computers and out of the computer screen, your y still doesn't change, right? In the x directions. So if you put it all together, you actually get all the points. That is, think of that as 3, let's say 3 units from the center of your screen, but it could be up and down, into the computer, outside the computer screen. So you will have a plane. It's like a paper. It's like a flat. There's flat surface. Okay, so it's like a paper plane go perpendicular to your computer screen, and vertical. Okay, so that gives you the graph of this equation y equals 3. When we write, I'm gonna write a few. So we need to describe this surface. So the surface here is it represents the vertical surface. We usually reference to one of our coordinate planes, XY, XZ, and YZ plane. In this case, you're going to see that this is actually parallel to the XZ plane. XZ plane. Okay, so it represents the vertical surface that that is parallel to the XZ plane. Okay, and it parallel to the XY plane, but it's actually it go through. You see the y-axis, the 3 on the y-axis, so intersect the y-axis at 3. Y-axis at the point. You want to be precise. This point here, what's x coordinate? The x coordinate is 0. The y coordinate is 3. What's the z coordinate? The z coordinate is also 0. It's on the y-axis. Okay, so that's what it represents. Now, if you look at the part B, can you graph the equation x squared plus y squared equals 4? Okay, so again, in the plane we have this circle. In the plane we have this circle in the xy plane. The circle is centered to origins and with the radius 2. Now again, now xy plane is actually the flat surface, the horizontal surface here. So we have an x-axis point toward you, y-axis to the right. You're gonna see, see I counted 1, 2, and it's 1, 2, negative 1, negative 2, negative 2. So if you graph it here, the circle in the plane would be this one. So to go through 2, negative 2, 2, negative 2. I think my scale is not so perfect. that is will be like this. Again, it should be a circle, right? So it's a circle in the xy plane. Now, again, there's no z. So what it means is when you have z equals 0 in xy planes, you have a circle. That's what I just draw. When you have z equal 1, and that is when z equal 1 is here, then you still have a circle in the plane z equal 1. So it's going to be another one on the top, it's just like 1 unit above. Z equal 2, then you have another circle above. And when z equal -1, you have this. So if you put it all together, you're going to see that now we have a whole bunch of circle, one stack upon on the top of the other ones. So you actually end up with a graph going like a circle and a whole bunch of circle, one on top of the other. And you see that we're going to have a cylinder. So the graph of x squared plus y equal 4 is now a cylinder. Where is the center? See, it's a here. So this d-axis will be this axis of the cylinders. Okay, the radius still 2. Okay, and but what's the height? It's go all the way up and down. There's no z, so go to positive and negative infinity. Okay, so here's my description. For B, it represents the cylinder with radius 2 and the z-axis the axis. We call that axis the axis of symmetry. This is symmetry, right? So just like a center, the cylinder. Okay, now we look at the next part is the number 2. You describe the regions represented by the following inequalities: x squared plus y squared less than 4. Now again, in the plane, what does that mean? What does that look like when you're looking at in the plane? So what happened is you see the let's say the difference between these two, that's an equal. So that represents all the points on the circle. But if you have less than, so that represents all the points inside of the circle. Inside the circle. Okay. So in the plane, xy plane, it represents all the points inside of the circle, x squared plus y squared equal 4. Now, likewise, you can see we have x squared plus y squared less than 4 instead of equal 4. When you have equal 4, it represents this cylinder. So that means this geometric objects, the cylinder itself. But then when you have less than 4, that represents all the points. It's actually inside. Okay. So you actually have the points of the solid, actually this time, of the points inside of the cylinder instead of on the cylinder. Okay. So here for 2a, The answer is it represent all the points inside, strictly inside the cylinder with equations or with equation. I'm going to repeat the above. I don't want to repeat the above actually, so I'm going to write with equation x squared plus y squared equal 4. So what I mean is it's really the points inside the cylinder with these equations, but without the cylinder, I describe it up here. Okay, so C radius 2 and then axis of symmetry is the axis. All right, so finally, 2b. Can you describe the regions that represent by this inequality, z less than or equal to 3 and greater than or equal to 2? Now, whenever you graph inequalities, you always graph the equation first. Like how to graph this inequality, I graph the x squared plus y squared equal 4 first, and then they're going to figure out that it's actually inside instead of on. Same thing for the inequality in part B. You have to figure out the equation first. So what is graph of z equal to? And what is the graph of the z equal 3? Now, similar to the one you see that y equal 3, you see that is the plane, right? Because y is always 3. Here's the same. You're going to figure out what is the surface with z equal 3 and z equal 2. So where is z equal 2? Z equal 2 is here, right? So all the points with z equal 2 will be on the plane. So here is the plane z equal 2. There. Okay. And then the z equal 3, so it's a set of all the points that has the height 3, right? Z equal 3. So we're going to have a second plane that's kind of 1 unit above, and they cut through the z-axis right here. Now, what is all the points satisfy this inequality? Z less than or equal to 3, bigger than or equal to 2. So see that it's going to represent all the points actually in between. You see that? It's in between the two. Right, so it's going to be in between the two planes. So the answer is it represents the points inside, or I should say in between, and now here's the difference. I have z equal 2 and z equal 3. So that means all the points, that on the z plane z equal 3 and z equal 2 actually count. All of them count because it's an equal sign. So not just in between, but on the planes z equal 2 and z equal 3, actually on the horizontal plane to be precise. Okay. Right, so I'll finish this part one of the video here.